Welcome back, everybody, to our new unit on parametric equations. And as you may recall, we talked about how parametric equations are like regular equations, except there's an additional variable that is in control of what's going on. In this case, it is t. So notice, of course, that t is ranging from -2 to +2. And we now can write up like a little txy chart to see what's going on with our equation without really knowing what the equation is. So we're going to do this kind of by an elementary way of working through it. So I'll pick some numbers for t, -2, -1, 0, 1, and 2. Just plug those in to the individual equations. So in the first case, I'm putting in right over here for t, I'm going to put in the -2 to find x. I get 3, it looks like. And then I do it next door for the y value, and I get a -4. All right, so now I'm just plugging and chugging here with my numbers. So in the second case, I'm coming up with a 0 here, and I get a -2 here. Speedy as I go, -1 over here, 0 for the y value, and then again another 0 here, and then in this case I end up with a 2. And the last part is going to give me another 3. So notice the symmetry here with the x's, but not so with the y values. We have the x's showing some interesting things there. So let's go ahead and plot these. We have 3, -4. So we'll go over to our coordinate plane. Here we've got 3, -4 down here. We've got 0, -2, 0, -2, so somewhere over here. And we've got -1, 0 about here, and 0, 2 up there, and then of course our last point is 3, 4, which is up here somewhere. All right, you can almost imagine that that looks a little bit curved-like, sideways parabola perhaps, but the most important part is the fact that this graph starts at 3, -4, which is down here. So I'm going to put an A right there. So I'd prefer that you folks put an A there, meaning that's your starting position, and it looks like the graph curves around and stops there. Now we don't continue this. We stop it here. This is a part of what looks like a parabola anyway. And we started at part A, and it looks like the graph is proceeding around in this direction, and we end at B over here. All right, so that's one of the things that we do. You're not required to label these graphs as long as you have something like this. If you don't have this chart, then I would like to see that graph labeled with at least, excuse me, at least a few points. Now, one last thing we can do is notice that since y is equal to 2t, we could also say that t is equal to y over 2, and we could take this y over 2 and plug it in right there. That would give us x is equal to y over 2 quantity squared minus 1. And as I simplify that out, I would see that that is a sideways parabola, and we can graph that. But the error that you might make in a problem like this is that you might be tempted to graph the entire parabola. And of course, we see that that's not the case. This is just a part of it. Let's move on to the second of the 3 examples that we have here. In this case, we're going to do something called eliminate the parameter. So by eliminating the parameter, we're essentially saying, let's get rid of the t value and see what happens from there. So if I did that, I think the first one would be the easiest. I could square both sides and get x squared is equal to t. And then I would substitute that into the other equation here, and I would get y is equal to 1/2 x squared plus 1. So that's wonderful because I have a very nice example here where 1/2 x squared is a parabola and moved up 1 unit here, and then it looks like it's going to be a little bit different. If I plug in, just for transformation purposes, it's going to be a wider parabola. So I'm going to dot this in because, remember, this is a parametric equation, so we don't necessarily graph the whole thing. In this case, I guess I could plot another point. Let me plug in a number like 2. If I plug in a number like 2 here for x, I would end up with 3. So here's 1, 2, 3. So I'm up here at 2, 3. So just put that in there as an ordered pair. Okay, so I'm going to just label that. Okay, obviously, there's another one over here at -2, 3 as well. Okay. So what's different about parametric equations is the fact that in this case, the t is restricted. So the domain of t t has to be greater than or equal to 0. If that's the case, then we would say that x, the answers for x are also greater than or equal to 0. And notice that's because we have a principal square root of t. So if that's the case, then we must be talking about only half of the parabola. Now, what is not really shown, and in this case it's here, um, it's really hard to tell in this case that whether the graph goes one way or another. Now, if you jump back to the previous example, I actually made an arrow because I was using, excuse me, the smallest, for a down here, I was using the smallest value of t and ending with the largest value of t. Now, if we go along that same line, then in this example, we would say the arrow should go in this direction because the t value is starting at 0 and going to infinity. So that would be how we would write that out. And I'm just going to put a little 1 there to note that. Okay, so that's our second example. Let's go to example number 3. Example number 3 looks really nasty, but it also starts to lend some information about some things that are going to happen later in the course, and that is how do we get rid of that parameter t? So let me see if I can help you out with that. Obviously, when t is going from 0 to pi, that makes perfect sense since we have a sine and cosine in our problem. So let's start with this x value. X is equal to 5 cosine t, and I'm going to write over here y equals 2 uh, sine t. All right, that's going to be fun. First thing I'm going to do is I'm going to square both sides. And the reason I'm going to do that is because there's no relationship between cosine and sine that I can use here. But I do know that in equations there's a relationship between sine squared and cosine squared. So x squared is equal to 25 cosine squared t. And then in the second one, y squared equals 4 sine squared t. So, I have to kind of think about this for a second, but isn't it true that x squared could be written as 25 times 1 minus sine squared t? Oh, that's interesting because I have a sine squared t right here. So therefore, sine squared t is equal to y squared over 4. So then I could substitute that over here, and I now have eliminated my parameter. So x squared is equal to 25 times 1 minus y squared over 4. Oh, that's just wonderful. Okay, so I think I've done a pretty good job. I'm going to divide by the 25 on both sides, get x squared over 25 is equal to 1 minus y squared over 4, and bring the y squared over 4 to the left-hand side. I now have x squared over 25 plus y squared over 4 is equal to 1. I'm going to box that. That is an ellipse. We've seen this before. So in this case, this is a very simple ellipse. It's one that has a center at the origin. So I'll just sketch this out briefly here. It looks like it has vertices out here at 5 and negative 5, up and down here at 2 and negative 2. Now today is not a review of the ellipse by any means, but this is the ellipse that we have. I've got a really pretty looking ellipse and centered at the origin. Okay, now the question really is, where does it go? Where does the ellipse go according to our parameter? So let's start over here. It says that t is going to go from 0 to pi. Now if I plug in a 0 for this t, it looks like x is going to equal 5 times the cosine of 0, which would be 5. So x is going to start at 5, and then if I put a pi in there for x, and so in other words, I'm going from positive 5 all the way to negative 5 since the cosine of pi is negative 1. So let's take a look here. It looks like our x values are going from way over here. So I'm going to, sorry, let me erase that. I'm going to put an a over here because I know that's my starting point, and I'm going to put a b over here because I know that's my ending point. The real question now is, does it go on the top half or the bottom half of our ellipse? And going back over to here, one more time, we see that the t values are going from 0 to pi for the sine t as well, and those are positive answers, so the y values are positive. So now I'm going to put this in solid. I'm going to put it just like this, and my arrows are going to go in this direction. Okay, so it's saying I'm moving in that direction according to the t value. We will do more of these problems coming up in more challenging examples, and we'll also learn how to use the graphing calculator to help us with these parametric equations. I hope that helps get you started. Good luck on your My Math Lab work tonight.